Hello and welcome to Lesson 1E, Compound Inequalities. I can graph one variable inequalities and compound inequalities on a number line. So statements joined by and are considered a conjunction, which is the set of numbers common to both inequalities or the intersection of those inequalities. We would write this in shorthand as A intersect B with an upside down U. And when I'm graphing these, my and statements are where my two inequalities are going to overlap. So let's take a look at what that looks like here. So for example, if I've got the inequality x is less than 3, that would graph at 3 and it would go strictly less than, going down here. And x is greater than 0 would be at 0 and it's going up from 0. The inequality x is less than 3 and x is greater than 0 is where these two overlap. And if you look, they're overlapping in this space here. So that means that my final solution is really between 0 and 3. And so my final answer is the inequality 0 is less than x, which is less than 3. And that would be my final answer here. So let's look at a couple more examples. If I have the inequality x is greater than or equal to -4, that would mean I'd have a closed dot on -4 and would graph up from there. X is less than or equal to 2 would be a closed dot on 2 and down from there. And so the intersection of these, x is greater than or equal to -4 and x is less than -2 would be where these both happen, which is between these two values here. So my final answer ends up being -4 is less than or equal to x, which is less than or equal to 2. So let's keep going. There are some more interesting occurrences of this actually. Let's take a look at x is less than -2. Well, that's open circle on -2, going down from there. X is greater than 2 is open circle on 2, going up from there. And when I look at this, there's no place on the graph where these intersect. There's no place where they both have drawing. Therefore, my final solution is a completely blank number line because there is no solution. We would say it's an empty set. So let's look at another one. Here I've got x is less than 4, so open circle on 4, drawing downwards. X is less than 1, open circle on 1, drawing downwards. And if I want to know where they intersect, when I've got where is x less than -4 and x is less than 1? Well, that's simply from 1 downwards. So my final answer here ends up being x is less than 1 because it's where they both occur. Now, let's now put that up against a disjunction where statements are joined by the word or. A disjunction is the set of numbers which is common to both sets or considered the which is considered the union of the sets. We would denote that by A union B. So that's a right side up U this time. And the union basically is going to be where any shading occurs. So all shading is considered the union. So let's take a look at an example. If I've got the value x is less than -3, that would graph as open circle on -3, down from there. X is greater than 2 would be an open circle on 2 and up from there. And when they're joined by the word or, that means we're going to take all things that are shaded, no matter where it is. So that means I get to keep this piece and I get to keep this piece. Everything is accounted for. So my final answer ends up being the phrase x is less than -3 or x is greater than 2. That's my final answer. So notice if this was an and, this would be no solution, but because it's an or, we take everything. So if we're looking at this next problem here, x is less than 3, that'd be an open circle on 3, shading down. X is greater than 0 is an open circle on 0, shading up. You can tell that there is, between these two diagrams, there is a line drawn for every single value in our number line. Therefore, the solution here is the whole number line or all real numbers. Now we've got x is less than 2, so that's an open circle on 2, shading downwards. X is greater than 2, open circle on 2, shading up. I'm joined by an or. Almost every single point of the number line is accounted for, except because these are both open circles on 2, both of these inequalities are leaving 2 out of their solution set, so I still have an open circle on 2, but we happen to shade both up and down from there. So my solutions are all real numbers except x cannot equal 2. So that's my final answer, x cannot equal 2. If we've got x is less than 4, that's an open circle on 4, shading down. X is less than 1, open circle on 1, shading down. X is less than 4 or x is less than 1, any place where there is shading we keep. Well, there is shading, there's a line drawn on all of these points from 4 downwards because x is less than 4 is including x is less than 1. So my final answer is x is less than 4. Just like that. All right, let's take a look at some of these compound inequalities where you guys are going to try some of these. Let's do the first 2 together, and then I'm going to go, and then I'll let you guys try some. We'll check our answers. So if we've got the word or means we take all shading. So if I've got x is less than or equal to 2, that means I've got a closed dot on 2 and I'm shading down from there. X is greater than -1, I've got an open circle on -1 and I'm shading up from there. Because we're taking all pieces that are shaded, well, there is a line drawn marking every single line on the number line. So my answer is the whole number line or all real numbers is my final answer. Whereas when I look at this problem, my word joining here is and is just where I take the overlap. So I'm looking only for the overlap in this next piece. So I've got x is less than or equal to 2, so that's a closed dot on 2, shading down. X is greater than -1, open dot on 1, shading up. I'm looking for the overlap. Well, they're only overlapped between -1 and 2, so that's my final graph. So the final answer is -1 is less than x, which is less than or equal to 2. And that would be my final answer. All right, guys, I want you to go ahead and try question 3 on your own right now. Go ahead and take a look at 3. Because it's an or statement, you're taking everything, so your final answer should be x is less than -1 or x is greater than or equal to 2. All right, guys, take a minute and try number 4. It's an and graph, and when I graph them, there is no overlap, so there is no solution for number 4. All right, take a look at number 5. This is an or graph, so I want to take any and all drawing in the picture. And so my final answer is x is greater than or equal to -2. Moving right along, guys, I want you to take a look at number 6 now. So looking at number 6, it's an and graph, so I want to take the overlap. The only overlap is from x is greater than 3, so that's my final answer. And go ahead and take a look at number 7. So in number 7, that's an or graph, so I want to take any and all drawing I see in the picture, which is just from x is less than or equal to 3 would be my final answer. And last but not least, let's take a look at number 8. So in number 8, it's an and equation, so we're going to take the overlap, so my final answer is just x is less than 2. All right, guys, we're going to switch gears a little bit and look at solving inequalities or 3-part inequalities. So the first type of inequalities we're going to look at are ones where there's only one x in the equation. And these are really just like solving equations, except you really have 2 other sides you're considering. So I still want to get the x by myself. So my first step here is I'm going to add 1 to all sides, all 3 sides, which is a little bit different than what we're used to. So I get -6. Is less than or equal to 3x, which is less than 12. I'm then going to divide all 3 sides by 3, and I end up with -2 is less than or equal to x, which is less than 4. And so when I graph that solution, it's going to look like I've got -2 and 4, zeros in between them, there'd be a closed dot on 2, an open dot on 4, and it's the shading in between them. So that's how I graph that solution. This next equation, b, the easiest way to solve it is to multiply everything in the equation by 12 to kill the denominator, because fractions are not our friend usually. So I end up with 5 is less than 1/6 times 12 is going to get me negative 2x plus 3/4 times 12 is going to get me 9, which is less than or equal to 11 because the 12s cancel. I'm going to subtract 9 from all sides. I get negative 4 is less than negative 2x, which is less than or equal to 2. And when I divide by the negative 2, remember, whenever you divide by a negative inequality, all of your signs flip. So I get 2 is greater than x, which is greater than or equal to 1. So when I graph this, the lowest value is 1, the highest value is 2. I've got a closed circle on 1, an open circle on 2, and we graph in between just like that. If we wanted, that should be a negative 1 because I had a moment, friends, with a 0 in between. Which means if we were to rewrite this as an inequality in the order that we usually like, it'd be negative 1 is less than or equal to x, which is less than 2. Let's take a look at C. On C, I'm also going to multiply by 6 to kill the denominator. When I multiply my first fraction by 6, the 3 and the 6 cancel, leaving a 2, so I get 5 times negative 2, which is negative 10, is less than. The 6's just cancel in this piece, so I get 4x plus 2, which is less than or equal to 1/3 times 6 is 2. I am now going to subtract 2 from all sides, so I get negative 12 is less than 4x, which is less than or equal to 0. Then I'm going to divide by 4, so I get negative 3 is less than, just x. I had a moment, friends, is less than x, which is less than or equal to 0. So when we graph this on the number line, we go between negative 3 and 0. I have an open circle on negative 3, closed circle on 0, and we draw in between them. All right, the easiest thing to do on D, again, I want to clear the fraction first, so I'm going to multiply everything in this by 3. So I get negative 12 is less than or equal to negative 2x plus 5, which is less than or equal to 3. Subtract 5 from all sides, I get negative 17 is less than or equal to negative 2x, which is less than or equal to negative 2. And I'm going to divide everything through by negative 2. And when I divide by a negative, all of my signs flip. So I get 17 over 2 is greater than or equal to x, which is greater than or equal to 1. I'm going to rewrite this in least to greatest format because it just is a little bit nicer to look at that way. So it becomes 1 is less than or equal to x, which is less than or equal to 17 over 2. So when I graph this solution, I've got 0 is not even in between them, but a 0, 1, 17 over 2. I've got a closed circle on 1, closed circle on 17 over 2, and we shade in between. So the next examples are a little bit different because what's going on here is you've got x's in all 3 pieces of the inequality. And when that happens, you're going to solve them by splitting them into 2 inequalities and joining them with the and phrase. And the way you're going to split the inequalities is you're going to take the first 2 pieces and make them an inequality, and then the second 2 pieces and make them an inequality. So what that's going to look like is 7x minus 1 is less than or equal to 7 plus 5x. And we're going to use the phrase and 7 plus 5x is less than or equal to 3 times 1 plus 2x. So what I've got is I've got these 2 pieces, and then I've got these 2 pieces joined by the word and. And now I'm going to solve both of these. First thing here, I'm going to subtract 5x over here to get 2x, and I'm going to add the 1 over here to get me an 8. 2x is less than or equal to 8, which when I divide by 2 gets me x is less than or equal to 4. This side, I'm going to distribute the 3. So I get 3 plus 6x is less than or equal to 7 plus 5x. And I'm going to subtract the 5 over here, subtract the 3 over here. I get 4 is less than or equal to x, which, again, these are joined by the phrase and. So if I rewrite this, I get x is less than or equal to 4 and x or is greater than or equal to 4. So when I graph these guys, because this is an and phrase, I need to graph them to see the final solution. We have our graph, we have a 4. One of them graphs less than or equal to 4. One of them graphs greater than or equal to 4, and is the overlap. And there's really only one place where they overlap, and that's right at 4. So my final solution is x equals 4. So let's look at another one of these. Again, I'm going to split this into 2 pieces. I'm going to take my first 2, and I'm going to take my last 2, and they're going to be joined by the term and. So I have 2x plus 3 is less than or equal to 3x minus 5, and 3x minus 5 is less than or equal to 2 minus 4x. So let's go ahead and solve these guys. I'm going to subtract 2x over here, add 5 over here to get that x is less than, or is 8 is less than or equal to x, or if I rewrite that, that's x is greater than or equal to 8. This side, I'm going to add 4x over here to get 7x, add 5 over here to get 7, so I get x is less than or equal to 1. Again, these are joined by the word and. So now we want to look at them on the number line. I've got a 1, I've got an 8. The 1 graphs less than or equal to 1, so it goes down. It's close dot. 8 is greater than or equal to, so we go up. Because and is an overlap, there is no overlap in this graph. So my final graph is completely empty with a 1 and an 8, and there is no solution. All right, moving right, oh, that's the end of our lesson, guys. If you have any questions, please come to see us, and y'all have a great day. Thank you.